According to the National Electrical Code, specifically Article 200.6, the grounded conductor in a three-phase corner grounded delta system must be identified with the color gray, not white. This is a very important distinction to make because using the incorrect color can lead to safety hazards and code violations. To fully understand why the correct identification is crucial, let's first define what a corner grounded delta system is. A delta system is a type of three-phase electrical system where the three phases are connected in a closed loop, resembling the Greek letter delta. In a corner grounded delta system, one of the phase conductors, effectively a corner of the delta, is connected to ground. This type of grounding provides a return path for fault currents, helping to ensure the proper operation of overcurrent protection devices like circuit breakers or fuses. Now let's delve deeper into the specifics of conductor identification as outlined in the NEC. The purpose of conductor identification is to clearly distinguish between different types of conductors within an electrical system, such as grounded conductors, ungrounded conductors, and equipment grounding conductors. This helps to prevent accidental connections that could cause electrical shock, fire, or equipment damage. Article 200.6 of the NEC deals specifically with the means of identifying grounded conductors. Grounded conductors are those that are intentionally connected to ground, providing a return path for current under normal operating conditions. They are typically identified by a continuous white or grey outer finish, or by three continuous white stripes on other than green insulation along their entire length. However, there are specific exceptions and clarifications outlined in the code. NEC Article 200.6 generally states that an insulated grounded conductor of number 6 American wire gauge or smaller shall be identified by a continuous white or grey outer finish, or by three continuous white stripes along its entire length on other colors than green. For conductors larger than number 6 American wire gauge, identification can be achieved by distinctive white or grey marking at the terminations. However, Article 200.6 provides a specific exception for three-phase corner grounded delta systems. In these systems, the grounded conductor must be identified by a continuous grey outer finish. This requirement is in place to avoid confusion with other types of systems where white is permitted. It's crucial to note this exception because misidentification can have serious consequences. Using a white conductor as the grounded conductor in a corner grounded delta system could lead someone to incorrectly assume it's a neutral conductor from a different type of system, potentially resulting in improper wiring and dangerous situations. Now, let's explore why the NEC makes this distinction for corner grounded delta systems. The rationale lies in the fact that in a corner grounded delta system, the grounded conductor is actually one of the phase conductors. Since it carries the same voltage as the other phase conductors, it's treated differently than a neutral conductor in a Y system, which is typically at or near 0 volts. The grey color helps to visually differentiate it and prevent accidental connections that could occur if it were mistaken for a neutral. To further clarify the concept, let's consider an example. Imagine a commercial building with a three-phase corner grounded delta system powering its lighting and HVAC equipment. If the electrician mistakenly uses a white conductor for the grounded conductor, another electrician working on the system later might assume it's a neutral and try to connect it to a device expecting a neutral, such as a single-pole breaker used to power a 120-volt circuit. This could result in a direct short circuit, potentially causing an arc flash, fire, and serious injury. Therefore, adherence to the NEC color coding requirements is paramount for electrical safety. The NEC is a comprehensive document, and understanding its specific requirements, especially those related to conductor identification, is essential for anyone working with electrical systems. Always refer to the latest edition of the NEC for the most up-to-date information and consult with a qualified electrical inspector or engineer if you have any questions. Understanding the specific requirements outlined in Article 200.6 regarding the identification of grounded conductors in three-phase corner grounded delta systems is critical for electrical safety and code compliance. Remember, the grounded conductor in this specific system must be identified by a continuous grey outer finish to prevent confusion and potential hazards. Therefore, it is very important to understand the National Electrical Code. Let us examine some other critical aspects of conductor identification and safety practices within electrical systems. Firstly, it's important to recognize that the NEC outlines different color codes for different types of conductors, including grounded conductors, ungrounded conductors, and equipment grounding conductors. Ungrounded conductors, also known as hot wires, typically use colors such as black, red, and blue in a three-phase system. Equipment grounding conductors, which provide a path for fault current back to the source, are identified by a continuous green color or a green color with one or more yellow stripes. Secondly, the NEC specifies the acceptable methods for identifying conductors at their terminations. This includes the use of colored electrical tape, paint, or other suitable marking means. It's crucial to ensure that markings are durable and easily visible to prevent misidentification over time. Thirdly, when working with existing electrical systems, it's essential to verify the conductor identification before making any connections. This can be done by using a multimeter to measure the voltage between the conductors and ground, as well as by visually inspecting the conductor markings. If the conductor identification is unclear or questionable, it's always best to err on the side of caution and consult with a qualified electrician. Fourthly, it's important to be aware of the potential hazards associated with improper conductor identification. Misidentified conductors can lead to electrical shock, fire, and equipment damage. For example, if a grounded conductor is connected to an ungrounded terminal, it can create a short circuit that can cause a fire. Similarly, if an equipment grounding conductor is not properly connected, it can leave electrical equipment vulnerable to dangerous voltage buildup, posing a shock hazard to anyone who comes into contact with it. Fifthly, the NEC provides specific requirements for conductor sizing, ampacity, and overcurrent protection. These requirements are designed to ensure that conductors can safely carry the intended load current without overheating or causing a fire. It's crucial to select the appropriate conductor size and overcurrent protection device based on the specific application and the NEC tables and calculations. Sixthly, the NEC requires that all electrical work be performed by qualified individuals who have the necessary knowledge and skills to perform the work safely and in accordance with the code. It's important to hire a licensed electrician for any electrical work that you're not qualified to perform yourself. Seventhly, regular inspections and maintenance of electrical systems are essential for ensuring their continued safety and reliability. These inspections should be performed by qualified personnel and should include a thorough examination of all conductors, connections, and overcurrent protection devices. Any deficiencies should be corrected promptly to prevent potential hazards. Eighthly, it's important to educate yourself about electrical safety practices and to follow these practices whenever you're working with electrical equipment or systems. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and using insulated tools. Ninthly, the NEC is constantly evolving to reflect new technologies and safety concerns. It's important to stay up to date with the latest edition of the NEC and to understand any changes that may affect your work. Tenthly, local jurisdictions may have additional electrical codes and regulations that must be followed in addition to the NEC. It's important to check with your local building department to determine if there are any additional requirements that apply to your specific project. By adhering to these safety practices and code requirements, you can help to ensure the safety and reliability of electrical systems and prevent potential hazards. Remember, electricity is a powerful force that must be treated with respect. Always prioritize safety and consult with qualified professionals when necessary. Moreover, consider the importance of proper labeling and documentation in electrical systems. Accurate labeling of conductors, circuits, and equipment is crucial for facilitating maintenance, troubleshooting, and future modifications. The NEC requires that all electrical equipment be clearly labeled with its voltage, current, and other pertinent information. This information helps electricians and technicians to quickly identify the equipment and understand its operating characteristics. Additionally, detailed documentation of electrical systems, including wiring diagrams, panel schedules, and equipment specifications, is essential for maintaining the system's integrity over time. This documentation allows future workers to understand the system's design and operation, making it easier to perform repairs, upgrades, and expansions. In addition to labeling and documentation, consider the role of grounding and bonding in electrical safety. Grounding is the intentional connection of a conductive object to the earth, providing a low impedance path for fault current to flow back to the source. Bonding is the process of connecting together all metal parts of an electrical system, such as conduits, enclosures, and equipment housings, to create a continuous electrical path. Grounding and bonding work together to minimize the risk of electrical shock by providing a lower impedance path for fault current to flow back to the source, tripping the overcurrent protection device and energizing the circuit. The NEC provides specific requirements for grounding and bonding, including the size and type of grounding and bonding conductors, as well as the methods for making connections. Proper grounding and bonding are essential for protecting people and equipment from electrical hazards. Furthermore, explore the importance of surge protection in electrical systems. Surges are transient overvoltage events that can damage or destroy electronic equipment. They can be caused by lightning strikes, power grid switching, or internal equipment malfunctions. Surge protection devices, also known as transient voltage surge suppressors, are designed to protect electrical equipment from surges by diverting the excess voltage to ground. The NEC recommends the use of surge protection devices in certain applications, such as dwelling units and critical facilities. Surge protection devices should be installed at the service entrance and at downstream locations to provide comprehensive protection. When selecting surge protection devices, it's important to consider their voltage rating, surge current capacity, and response time. Moreover, recognize the significance of arc flash protection in electrical safety. Arc flash is a dangerous phenomenon that occurs when an electrical arc is formed between two conductors or between a conductor and ground. Arc flashes can generate intense heat, pressure, and noise, causing severe burns, blindness, and even death. The NEC requires that employers conduct arc flash hazard assessments to identify potential arc flash hazards in the workplace. The assessment should determine the incident energy exposure and the appropriate personal protective equipment required to protect workers from arc flash hazard. The NEC also requires that employers provide arc flash training to their employees and that they implement measures to reduce the risk of arc flash incidents, such as using remote racking devices and insulated tools. Arc flash protection is an essential aspect of electrical safety, and it's important to take steps to mitigate the risks associated with arc flash hazards. Let's examine the evolving landscape of renewable energy systems and their integration into the electrical grid. Renewable energy sources, such as solar, wind, and hydro, are becoming increasingly popular as a way to reduce our reliance on fossil fuels and mitigate climate change. However, the integration of renewable energy systems into the electrical grid presents unique challenges, such as intermittency and voltage fluctuations. The NEC addresses these challenges by providing specific requirements for the installation and operation of renewable energy systems. These requirements cover topics such as grounding, wiring, overcurrent protection, and disconnect means. The NEC also addresses the use of energy storage systems, such as batteries, which can help to smooth out the intermittency of renewable energy sources. As renewable energy systems become more prevalent, it's important to understand the NEC requirements for their safe and reliable operation. Always consult the latest edition of the NEC and work with qualified professionals to ensure that renewable energy systems are installed and operated in accordance with the code. Consider the growing importance of electric vehicles and their charging infrastructure. Electric vehicles are becoming increasingly popular as a way to reduce emissions and improve air quality. However, the widespread adoption of electric vehicles requires a robust charging infrastructure. The NEC addresses the installation and operation of electric vehicle charging equipment, including charging stations, charging plugs, and charging circuits. The NEC provides specific requirements for grounding, wiring, overcurrent protection, and disconnect means. The NEC also addresses the use of energy management systems, which can help to optimize the charging of electric vehicles and prevent overloading of the electrical grid. As electric vehicles become more prevalent, it's important to understand the NEC requirements for their safe and reliable charging. Remember to consult the latest edition of the NEC and work with qualified professionals to ensure that electric vehicle charging equipment is installed and operated in accordance with the code.